Man, I'm having trouble with this problem right here. Alright, so right now I have this circuit, and I'm supposed to find the equiresistance of the total circuit and what is the current at the 10 mega ohms right here. But what I'm confused about, and what makes this problem a little bit more difficult, is that it has both a series and two little parallel circuits within this whole circuit. Can either Ben or Josh help me out with trying to make this problem a little bit easier?
Hello guys, my team and I are working on a circuit that has both a series and a parallel in it. First I'm going to show you how to find the total resistance in a series circuit. So total resistance is going to be the summation of all the resistance in it. I have three resistors here, so I'm going to say R1 plus R2 plus R3, and that will give me the total resistance in this circuit. Going back to Ohm's law, I can say V is equal to IR. Remember, your I is your current. So I is equal to V over R, equivalent. I is constant in a series circuit, alright? Now, if I'm trying to find the voltage I have on this resistor, I'm going to say V1 is equal to I, R1. To find the second one, I'm going to say V2 is equal to I R2, and V3 is going to be I. Remember, the current is always constant throughout the entire circuit. The summation of all these three should give me my V. So V1 plus V2 plus V3 should be equal to V. Thank you.
Okay class, so now I am here to discuss the parallel circuit. So to find the resistance in a parallel circuit, first of all we know that the voltage across the circuit is the same. So that's why we have V1 equals V2 equals V3. But to find the resistance, we have the formula voltage equals current times resistance. And to find the current, we have V1 over R1, which is the same as V over R, plus V2 over R2 plus V3 over R3. And so to find the total resistance within a parallel circuit, we have 1 over each resistance. So 1 over R1 plus 1 over R2 plus 1 over R3. That equals the inverse of the total resistance in a parallel circuit. And we know that the voltage is constant throughout the parallel circuit. Thank you.
Wow, okay, that helped a lot understanding an individual series and a parallel circuit. But can Jalen and Jamel help me out with actually putting them together?
Okay, so in order to find the total resistance of this circuit, we first must look at the circuit and decide whether or not it is parallel or in a series. Currently, right now in this circuit, there are two places where there is parallel. Here's one, and here's the other one. These both are in parallel. So in order to find the resistance of a resistor in parallel, you have to come over here and use this equation. 1 over R2 plus 1 over R3 will give us the total resistance over here in this area. And that put together will give you 90.91. And then you do the same thing for R4 and R5, which in total will give us 196.08 kilo ohms. Now then you put it back into the circuit, and now your newly circuit looks like this. And if this reminds you of anything, this is exactly in a series circuit. So in order to get the remaining total resistance, you have to add them all up in a series. And when resistors are in a series, you just add them up normally. So we added all of the resistance up normally in order to get the total resistance, which turned out to be 307.19 kilo ohms, or 307,193 ohms. And then we put it in here. So now we simplify from this part to this part of what the circuit looks like and got our total resistance.
To find the current at the 10 mega ohm resistor, we'll need the equation V equals IR, V being the voltage, I being the current, and R being the resistance. We'll move the equation around until we get I equals V over R. And then we'll come back and look at our circuit where we'll see that the current goes up and through this resistor, which is in series, so the current is equal to the total current. Then it will come through to these two resistors in parallel, where the current will split up, because in parallel circuits, the current is not the same throughout the circuit. They'll come back, and it'll be the total current once again, where it will split up in these two resistors. So, to find IT, we'll take the total voltage over the REQ, which is 50 volts over 307.19 kiloohms, which will give us 0.163 kiloamps. Okay. We know that as the voltage is going through, it's not always constant. Voltage is constant in a parallel circuit, but in a series circuit, it is not. So here we have a voltage drop, here we have a voltage drop, and here we have a voltage drop. So we'll be searching for the voltage drop at R45. So V45 would equal IT times R45, which would give us 31.96 kilovolts. Now we use that voltage to find the current at resistor 5, which is the 10 mega ohm resistor. So we take V45 over R5, as we have here, and then that will give us 0.003196 kiloamps. And to check our work, we can check for the current at resistor 4, which will be the same equation, just with resistor 4 in the denominator, and that will give us this current. And if we add those two currents together, they'll come and bring us the total current, because the current was split between the two resistors, which they did.
Oh, wow, that's great. Awesome, guys. Thank you so much. Now I fully understand how to solve this problem, and I also know a little bit more about series parallel circuits and kind of how they work together. So first, when we are trying to find the total resistance of this circuit, we have to kind of separate it into a few separate parts, with this, of course, being a series circuit with two parallel circuits kind of embodied in with it. So when we first are finding the resistance, we have to find the resistance of this parallel circuit, which is, of course, right here. It's going to be 1 over the inverse of R2 plus the inverse of R3, which is going to get our total resistance right there. Next, we do pretty much the same exact thing to this parallel circuit, and then we get our resistance right there to be that. Next, we just kind of simplify this down into a series circuit, kind of shown right there. And quite simply, when you are trying to find the total resistance of a series circuit, you add each and every resistance to get your total resistance. And we got 307.19 kiloohms. Kiloohms. And that's how we find our total resistance. Next, we have to find the current at the 10 mega ohms listed right here. And of course, how to find the current right there, we have to get the total current of the system, which is of course 50 volts over our resistance that we got. We have to next find the voltage drop listed right there, which is going to be 31.96 kilovolts, and that's going to be our voltage that's going to be right there. Next, once we are trying to find our current, we have everything that we need to find. We just put the voltage over the resistance at the resistor, and then we get our resistance, which is going to be 0.003196 kiloamps, which is going to be our answer. And now, just of course, to double check ourselves, we have to find the resistance here, and if they both equal the total current, then it checks out, and that will be our answer. So that is how we solve the current and the total resistance of this circuit. Thank you.